Hi, this is JP Miller with Reach. In the previous section, we just gave our contract or the front end the ability to connect to the buyer or the seller. And in this section, we're going to explore units and balances. And so we're going to explore parse currency and format currency. I like to think of these methods as parse currency parses currency to lowest atomic value. So it takes from a standard format to an atomic format. And if you think of atoms, right, like the smallest building blocks of all things, so atomic units of currency are the same way. It's like the smallest representation of a currency. So like pennies or gwei or microalgos are all examples of atomic units of currency. And whereas format currency creates the standard format of a currency, which includes like the whole number and the decimal, so like dollars and cents. And so this format currency converts from atomic to standard. But rather than me talking to you about it, let's hop into the code and build this together and explore this and see it for ourselves. So here we're going to begin around 11 and 12, where we've loaded our standard library. We're still in our front end. We're not going to edit the back end at all. And we are telling our users what network they're connected to. And so now we're going to share how many units they have in the standard format of currency and in the atomic format. So let's create a couple of console log messages. And we'll set up the standard unit first. And then we'll do the same theme, but for the atomic unit. So we'll parse the currency. Okay. And that's the only change we'll make in the code for this section. But now we get to run it, and we'll see our units. And of course, in the last video, we were connected to Conflux. In this video, let's run reach config again very quickly, and we'll connect to algorand. And then we'll get to see that our contract has been connected to all three of these networks here. And so we're currently selected to Conflux. We'll select one for algo, and we'll update these instructions here. My environment. Okay, and that's done. So now we'll do a reach run index seller, and we'll see that we're the seller. We should see that we're connected to algo, and we'll also have two new messages. So again, here we're pulling in our Algorand DevNet for the first time, and this is a good opportunity to talk about what a DevNet is. So DevNet is a simulated blockchain that Reach provides for the testing network. And so it acts in the same way that the real network does, the testnet does, but it runs on your machine through Docker. And so we're able to test faster. And our DevNet saves our developers time and simulates the real environment. Once you're happy with your DApp as a DevNet DApp, then you begin to test on testnet with signing the wallets, and then once you're past all of your tests, it's ready to go to mainnet. So that's usually the process that we develop our applications in with Reach. So this update will finish in a minute, and I'll see. Oh, here it is. So our role is seller, our consensus network is algo, and so our standard unit is algo, and the atomic unit is called a microalgo in this case. And it's really quick. If we want to see what the other units are, we can do a reach config for like ethereum. This will only take a moment, and then we'll run as the buyer. So we'll do a 3 as ethereum and copy and paste this information again. And now let's run as the buyer. And so you see it really is that easy to transfer from one consensus network to another as we're building, and here Ethereum loaded right up. So our role is buyer, consensus network is ETH, our standard unit is ETH, and the atomic unit of Ethereum is Wei. Okay, and so that concludes this section. In the next section, we'll be deploying our contract as the seller. So that will be quite exciting. All right, so we've just ran our new code and we see what our standard unit and our atomic unit is in a couple different networks. But this is kind of like we're very manual in the way that we're printing our statements. So we can save these standard library, like the standard library connector and standard unit, atomic unit. We can save these to constants that we can call at any time. So let's do that. So after line 13 here, well, I guess we'll be making a new line. So let's make a break at 11 and we'll create two new constants. We're going to create a constant of standard unit string, and that will be our standard library.standard unit. And then we'll create a constant of our atomic unit. Okay, and so now instead of needing to print the entire standard library statement, we can simply call, here on line 15, we can call SU_str. And on line 16, we can call AU_str. Boop, boop. Right on. And we can remove our connector name. We know who we're connected to, and that's okay. Good there. And we'll make a new line here. A new console message stated on our atomic unit. Okay. And so we'll see that we can print this. We're just proving to ourselves that we can print the same message, one with a constant and one with the dot notation. And so let's run that quickly. And this time, just to save time, we'll run this as only one participant. Okay, so tests have run and we see that our standard unit is ETH and the atomic unit is way, and that's the truth on both statements, or that is way on both statements. And so we see that we can print our statement either which way, as saving as a constant and calling that constant, or using dot notation. And using the constant in this case, it's more preferred way. All right, we'll carry on our edits, and this time let's show the actual amount of algo or micro algo or ETH or way that we have in the contract, right? And of course, in the DevNet, we are populating our participants with 1,000 units of the DevNet currency. Okay, so beginning after line 13 on a new line 14, we'll set up a new constant of 2 AU. So this will be 2 atomic units. And we'll take in a standard unit as an input and pass that to parse currency with SU as the argument. And then we'll have a constant to SU for standard units. And of course, this will take in our atomic units as an input. And this time we'll call format currency. Format currency takes in 2 arguments. The first one is our AU for the currency amount, and then the 4 represents how many decimal places we should show. So we're saying, hey, show me 4 decimal places. And we'll create a constant of SU bell, which will equal 1,000. And then we'll update our console messages. So let's set up our first console log message. Okay, and so this will say, hey, this is my balance as a standard unit, and then we'll set up it as atomic balance, Oop, there we go. And we'll print a message as the atomic units. Okay, and so that'll print our atomic balance and string. All right, and then our balance statement here, we'll edit this. So for this balance statement, we won't need both of them. We'll show our balance is to SU, the taking in atomic balance, and then show the string. All right, and then the atomic unit is, and just for fun, we'll keep showing the standard library dot atomic unit. And this again will show us that, yeah, we're still showing the same information. We're just saving this information in constants as a way to allow us to quickly call that information again in the future. So let's run this. And we ran as seller last time, so we'll run as buyer this time. And here we have our output. So the balance is 1,000 ETH and a whole lot of Wei. And again, the balance is 1,000 ETH and the atomic unit is Wei. And so we can see that we can show this information in multiple ways. And we can also show our currency either as a formatted currency or as atomic units. And in this case, we said we called for 4 decimal places, but because we have an even 1,000 ETH, we have an integer, and so we don't need to show the floating point values. Okay, so we've just seen our atomic and our standard units. So let's carry this forward. We can actually save all of this information in constants such as like iBalance and show balance, constants that make sense, variable names that make sense to an English, or excuse me, that makes sense to a human reader. And so let's update our code even more. So we're still in our index.mjs, and we'll carry forward here. And let's see, we're going to be at new line 13. So actually, we're going to remove line. Okay, and so we're going to be line 13, and we're going to start by removing this line 13, so we no longer need that. And then 14 will remain the same. 13 and 14 remain the same. We have new numbers, and rather than the standard unit balance, we're going to update this to an I balance. And we'll wrap that 1,000 in 2 atomic units. And then we'll have a new const of showcase. Or excuse me, show balance. And we'll tell our users what their balance is. Okay, so hey, I've got this balance for this account, and then we'll show that in a standard unit. Now remember the squiggly brackets there they are, and we'll put a period at the end for good punctuation. And we'll still print the atomic unit, but now we don't need any of this other information, so we don't need to show this information of balance or converting to the atomic units or printing the balance even more, because we now have the initial balance, the I balance, and we have the show balance. So we can remove all of those lines there. And there we go. It's a little more compact. It's easier to read. And we still have the the same standard.library or standard library.atomic unit, just so that we can see that difference. So let's run this bit and we'll see that. And we're going to change to algorand now, just so we get some different comparisons. I'm going to do this in a different way. So this time I'm going to do export reach connector mode equals algo. And that now connects me to algorand. And now let's do a reach run index seller. Okay. Oh, we have a, let's see. No, here it is. No. Did I reduce my messages? We don't show it. Okay. We're going to pretend like we never showed that. I'm sorry. Okay, before we run our program, so now that we've compacted this section, we won't have new information to show because we've just set up our balances, but we haven't told the console to print anything new. And so before we do, though, we'll update. So remember earlier we set up our test accounts with 1,000 units, right? But up here we're setting up that information in a constant called iBalance. So we want to update this area here. So let's get that updated. And we'll parse currency now to iBalance. Right. Okay, and so now we'll update this section. So instead of needing to run the entire standard library.parse currency, we can remove all of that because we call this an iBalance, this to AU, and we can follow this logic as we converting our standard library with a parse currency. And so we convert all of this. And all we need to do is call iBalance here. There you have it. And then we'll show our account. And so we'll restructure this. So we'll add our weight to show the balance of the account. Here we go. And then we still have our contract that we call to deploy. So this deploys our contract on line 30. And then we wait for our participants. And again, we'll await to show the balance for our other account because we know that we're going to have two participants, right? Buyer and seller. Okay, at this point, we'll give our code a run here. All right, pull up our terminal. And let's do a reach run index seller. And we'll be on algorand this time. And so we see that our role is seller, our atomic unit is way, and then we see the balance for both our seller and our buyer are at 1,000 Ethereum. Okay, so here in this section, we've explored our units and balances. And in the next unit, we'll deploy our contract using the seller. So be sure to check out the links for documentation, the source code, and additional help that you can receive as you work through this tutorial in the description below.